Hey everyone, welcome back to Cells to Cell. This is Heem, and that's Nick. And this episode, we're actually going to go over the basics and the differences between MSCs versus HSCs. So, an MSC is a mesenchymal stem cell, and an HSC is a hematopoietic stem cell. Now, Nick, when you first think of MSC versus HSC, what would you say the difference between the two are?
I would have to say, I wouldn't say location, because they can be found in similar locations, which we'll talk about in a minute. But I would say the different types of tissue they can make.
Right.
I think that's the biggest difference between the two. MSCs are going to be able to make more tissue, if that makes sense. It's going to be able to make more adipose tissue, muscle, cartilage, for example. Whereas HSCs, or hematopoietic stem cells, are going to make your blood-borne cells, so your red blood cells, your white blood cells, which would include your neutrophils, basophils, that kind of stuff.
So, on the screen right now, you're going to see a figure that goes over kind of like the lineage, and you'll see how at the top from MSCs will proliferate, and then they'll commit to their lineage, and then from that, they also have their entire maturation period. So, I'm going to go over the 3 on the left, and Nick can go over the 3 on the right. So, osteogenesis, chondrogenesis, and myogenesis kind of has to do with you becoming your osteocytes, your chondrocytes, and your myocytes. And these are bones, these are cartilage, and this is tissue. And you can see after they commit, they progress throughout their lineage, they differentiate, so then they finally become that cell, and then they mature to become the full tissue type. And the 3 on the right are...
Sorry, I can't see. I'm sorry, I'm blind. We have merostroma, tendogenesis, or basically making tendons or ligaments. And then you have adipogenesis, so that would be making adipocytes or fat cells. So like he said, they're going to choose their course, and then they're going to continue to become more and more specialized throughout their time. And what makes these cells, pick a specialized lineage? How does the body, or how would somebody who would take a parasite or an MSC out of the body turn it into, let's say, a bone cell, or turn it into an adipose cell?
So it's a great question, and I think people should be aware of this thing called your cell surface markers. So these are proteins that basically exist on the outside of the cell, on the outside. And if a scientist or a researcher wanted to take this MSC and turn it into a osteocyte, or if it wanted to turn into a myocyte to make bone or muscle, all you would have to do is you would take the cell surface markers that are predominantly present on a fully differentiated cell and put those same amount of proteins and the right combination of those proteins and put them on the stem cell. So it's really interesting because let's say if you wanted to become a lawyer, you would take somebody and give him a suit that a lawyer would wear and you say, hey, you're a lawyer. Or if you wanted to be a doctor, you take somebody and give him
a
white coat, or you give him some scrubs and say, now you're a doctor. So same basic kind of idea works with these stem cells. You take a stem cell, which is very pure, and it can be differentiated into many different things. You give them certain proteins to say this is what a cell would look like and has majority of these proteins in a normal, fully differentiated cell. Like right now, my bone or my fat or my muscle has certain proteins that are different than other ones. But if I wanted to make a stem cell into my fat, I would take my existing fat cell proteins, put those same proteins on the stem cell, and it would detect those proteins and turn and differentiate into that cell. And where would you find MSC? Then could you explain what a parasite is?
So MSCs can be found kind of all throughout the body, and describing what they can differentiate to is also where they're going to lie. So you're going to find MSCs in the muscle, you're going to find MSCs in the fat or in the adipose tissue, but you can also find them kind of in different what are called stem cell niches or different environments of the body. So MSCs are also known as parasites, and parasites are found wrapping around blood vessels all throughout the body. They actually can assist with some nerves and some nerve niches and in microenvironments, but mostly they're going to be found in like the fat, and that's where most of the studies using MSCs recently a lot of studies are using adipose tissue, but a lot of them it was bone marrow, right? Not muscle. A lot of them, I believe, a lot of the past studies use bone marrow MSCs, which I think is a good little bridge into what HSCs are and kind of how they differ from MSCs. So what would you say?
So HSCs, like we mentioned in the beginning, are your hematopoietic stem cells, and they're responsible for your lymphoid and your myeloid cells. And now in your myeloid lineage, you have your platelets, erythrocytes, granulocytes, and myocytes. And your lymphoid lineage, you have your T cells, your B cells, and you have your NK cells, which is basically your immune cells. Now these are two different types of stem cells, and HSCs exist mainly in large quantities in your bone marrow. You can't really find them elsewhere. You could find a few in circulation, but very, very little. And also depending on what is going on in your body. But like Nick said, your MSCs, your mesenchymal stem cells, can be found everywhere. And all it is, it's in each little microenvironment. So your bone's little microenvironment has an MSC, your fat, your neurons, your eyes, your everything has its own little MSCs. Whereas your HSCs can only be found in your bone marrow. And those are responsible for all of your blood products that are made, including your immune cells.
Naheem, I have a question for you. Which of the two are most active in the body, MSCs or HSCs?
Interesting, because MSCs can be found everywhere. I'm going to say those are the most active because there's a couple things, okay? MSCs can also be called medicinal signaling cells, meaning they have really good properties that do a lot of talking to each other. So I feel like they'd be really active because they release things called exosomes, which can help with healing and all these things. So not only can MSCs differentiate, but they can also do a lot of communication. So I would say they're the most active, but what's your answer?
I think you answered my trick question pretty well, because I was hoping you were going to talk about how HSCs would be proliferating more as you continuously need new blood. Mm-hmm. About every 100 days you have all new blood, which I think is super cool.
I did not know that.
I learned that in undergrad, which I thought was super. It's about every 100 days.
Okay.
But you're constantly making new blood. These HSCs are constantly working, even in adults. Hematopoietic stem cells are constantly at work.
Yeah.
Whereas in adults, MSCs are working really hard in other aspects. Parasites are not known to proliferate in the body, mm-hmm. but they are known to change microenvironments. They are known to support other stem cells and other cell niches, which makes them a very big player in the body in general. So I think you passed the trick question. And it's interesting to see the difference between when we talk about what cells are working harder, which cells are more important. They're all very important. They all have their own job. It's just how good are these cells at doing their own job, and do they need to be replaced by stem cell therapies? That's the biggest thing.
In a later video, we'll actually go over a few examples of when MSCs and HSCs work together and how they actually help each other in healing somebody. But the main thing I feel like we should focus on is that how MSCs are found everywhere, whereas HSCs are only found in the bone marrow. Mm-hmm. And how MSCs were called mesenchymal stem cells because they make the mesenchymal tissues. So you're going to have your bone, your fat, your muscles, those tissues, whereas your HSCs can mainly make your blood products.
Yeah, and I think that just goes to show that, when we talk about regenerative medicine and stem cells as a whole, it's just an umbrella covering, multiple, probably tens if not hundreds of different types of cells and different types of responsibilities that these cells have that, have been studied and will be studied and will be discovered. So I don't know. Anything else on the difference between MSCs and HSCs?
No, that's all.
Yeah, it's kind of a short one today,
Yeah.
but I think just a general video just to clear up, because we've been talking about MSCs and HSCs so much in the
Mhm.
past couple episodes that it might seem a little bit confusing to keep them straight, but just understanding that HSCs are found mainly in the bone marrow, whereas MSCs are going to be found all throughout the body. And while they both have different and separate jobs, they are both just as important in maintaining the body and its environment. So, anything else?
If there's one takeaway, just know that there's two different kinds of stem cells.
Yeah.
When somebody says stem cell, don't let them fool you and think a stem cell is just a stem cell.
Right. Yeah, they're from all throughout the body, and we haven't even gotten into induced pluripotent stem cells, which, Nobel Prize winner in 2012. They're absolutely incredible. So that will be a little bit further down the line when we get a little bit more of a basis. Maybe hopefully have some professors or PhDs, or we're even thinking about bringing on some students as guests just to see and hear their thoughts, because as this field is growing, it's important to hear from everybody, both those who have been in it and what people think going into it, and how that can affect both the mindsets of us, and those who are at the top and those who are just coming in. So, all right, well, that's been Cells to Sell. I'm Nick and that's Heem, and thanks for watching, guys.
See ya.